In this part I'm going to show you how to calibrate a pH meter. As you can see here, we've got calibration solutions. These are standards: pH 4, pH 7, pH 10. You'll notice that they're all different colours. We're going to choose to use the pH 7 to calibrate our pH meter. Alright, so now we're looking at how to calibrate a pH meter. So I'm putting the probe in here into the 7 buffer. I'm going to pull this over here so you can see the measurements and what I'm doing on the screen here. So what I'm going to do is I'm going to hit Cal Measure here, and that will change this to calibration here. Now you can see that it says 7.26 and it's down here it says 7.00. So that's what it's actually going to hold on to, will be that 7.00 once I hit enter. So I'm going to hit enter, and there you go, it's at 7.00. Don't worry about what this is doing down here. Just hit Cal Measure again, and you're ready to go with the measurement on your next solution. So rinse off the pH meter into a beaker with some DI water, and then you can put it in your next solution, or you can put it back in its house. So this is part A of the buffer and pH lab. So what Eve's going to do is find the pH of an NaCl solution. All of these beakers here are labelled, and we need about 25 mils. So she's going to pour about 25 mils in. We don't need exactly 25 mils, so she's not going to be too concerned about how much she's putting in there. She's going to eyeball it. That looks good, Eve. That's excellent. Right, go ahead and pour that into the beaker, please. You'll notice that we've lined these up behind the beakers as well to make sure that we don't mix up our solutions. Would you please turn on the pH meter? The pH meter gets turned on by the on-off switch. Now this has already been pre-calibrated, so what Eve is going to do, could you bring that into the shot please, Eve?
Yes. Or wait, this?
No, this is the probe, you're good. Alright, so what she's going to do is she's going to unscrew the bottom part from the bottom of the probe there. See, it's a little screw cap jobby there. Oh, is it not coming off? Alright, you can just pull it off then. There we go, that's alright, that'll be fine. So you can either unscrew it or just pull it straight off. I prefer to unscrew it, but if it doesn't unscrew, obviously, that's alright. So go ahead and stick that in. So what Eve is going to do, now just leave it in there, please. So as long as you've got about that volume in there, it should be enough to get a measurement on the probe. So you wait for it to stabilize, and if it's still not stabilized after a minute, just take whatever measurement it happens to show there. So Eve's going to write that down. Don't worry about saying what it is, just go ahead and write it down. So now what Eve is going to do is she's going to make up the next solution. So she's rinsing out the graduated cylinder a couple of times with water. There we go, to avoid any contamination. Don't worry if there's any water in there, it doesn't matter if it's a little bit wet. The molarity here is not really that important. What matters is what's in the solution. So again, Eve is going to make up this next solution. Again, she's not being too concerned. That's good enough. Alright. Yeah, let's go ahead and stick that in. Yay. Alright. Now what Eve is going to do, instead of just taking that probe and sticking it straight into the second solution, she's going to do what she's doing there, shake it off a little bit, bring it over to the waste beaker and rinse the bottom of the probe off with DI water. Then she's going to go ahead and stick the probe into the next solution. There we go. And that process is going to be repeated a couple of times, and of course they're going to mark down whatever result they get off the pH meter here. Okay, now Eve's going to put the pH meter away now that she's gotten her full results. She's going to rinse it off with DI water, and then she's going to put it back in its little house. There we go. Just push it straight in, and make sure that the probe is close to the bottom. There we go. It is? Excellent. Well done. So now what Eve's going to do is she's going to add 2 drops of Brom Cresol Green to each of these solutions. And as you can see, we've still got the beakers lined up, so we know exactly what's what. It's good. Okay, so what I'd like you to do, Eve, is just give each one a light swirl. So you'll notice you can get different shades here as well, so those should all be recorded too. Alright, now what Eve's going to do is she's going to pour each of those solutions into the waste container here, the waste beaker, and then you will follow the instructions of your instructor about how to dispose of that waste. Right, we're on part B now. So what Teresa is going to do is she's going to wash her chem plate. These are chem plates, or well plates as it's sometimes called. And she's got a waste beaker there. She's just rinsing them out, rinsing all the little wells out there with distilled water or DI water. Now these don't have to be dry, but she's going to do her best to get most of the water out. There we go. That's good, thank you. Now the idea here, now you're going to have to move off to the side here, Teresa, so I can get this into the shot. The idea here is that you're going to put 1 milliliter of each solution into a well, and then 1 drop of each indicator solution. It turns out though that 1 milliliter is about half the well, so you just have to fill the well up halfway and then add a drop of the indicator solution. So in this next step, we've already cleaned off the well plate, so now what we're going to do is we're going to put each of these solutions, this first one is HCl, and Teresa is going to half fill each of these well plates with the HCl. Half filling is about 1 milliliter. So she's going to do that for the first row there, because we've got 5 indicator solutions, and you can see them all lined up there at the back. There we go, that's good. And then after she's done that, she's going to take the next solution and she's going to put that behind the HCl. It's going to be more efficient to add all the indicators at once. You'll see what I mean in a bit, because I'm going to film that part of it as well. So presently what Teresa has done now, or almost done, is she's half filled the first row of well plates, 5 of them, with HCl. Now she's going to do the second row, and that's with the NaH2PO4. And she's just going to drop or squirt or whatever that solution into each of those. Then she will repeat the process with the HC2H3O2. So what we've got in the first row is the HCl, and then in the second row we've got NaH2PO4, and in the third row we've got HC2H3O2. First row, second row, third row, and there's 5 solutions to match the 5 indicators. The most efficient way to handle this now is for Teresa to grab the Brom Cresol Green, and she's going to put 1 drop of indicator into the first column there, which is going to be, first of all, the HCl, and then the NaH2PO4, and then the HC23O2. And she's going to do the same with Congo Red, and then at the end you're going to mark down all the different colors. So now we can see all of the solutions. They've had their indicators added. So just remember, in the front row we've got HCl, all 5 of those. In the second row we've got NaH2PO4, and in the third row we've got HC2H3O2, and then in the first column here we've got bromcresol green, Congo red, methyl yellow, thymol blue, and methyl yellow, or methyl violet, or violet at the end there. And these are all the different colors that we're getting in each of these wells. And I'm going to go ahead and put this above here so we can get a better shot of all of these different colors. So now what Teresa's going to do is she's going to clean off the well plate into the waste beaker. She's going to do that just by first of all pouring the stuff in. Hold it upright so everything goes in the beaker. There we go. And now what she's going to do, she's going to grab the DI water and she's going to clean out each of those well plates. And then after that, she's going to dispose of the waste per the directions of her instructor. Alright, we'll get part C. So what Chow's going to do is she's going to measure out 15 mils of acetic acid. That's HC2H3O2. That's the acetic acid. Now it doesn't have to be, well, yeah, let's try and get it as close to 15 as possible. You know she's using a 50 mil graduated cylinder, and the reason for that is because we're going to add 30 mils of water in a little bit. But let's try and get it fairly close to 15, please, Chow. So she's just squeezing it in now, getting it up to 15. She's going to put it in that beaker that's in front. Probably a good way to arrange it. Then they're going to be mixed at the end anyway, so they really probably don't have to be labelled even. Of course, when we're measuring with a graduated cylinder, we want to try and make it so the meniscus is on the line. So she's going to try and arrange it so the meniscus is on the 15. Okay, that's really good, thank you. Okay, so she's going to go ahead now and close that back up, and she's going to pour that into the beaker. Okay, now what she's going to do is she's going to rinse that graduated cylinder out into the waste beaker with a little bit of DI water. Wouldn't worry too much about it being completely dry. And now she's going to add the sodium acetate. Would you please bring the sodium acetate up to the camera here? You can see a little bit lower, there we go. NaC2H3O2, that's the sodium acetate, that's the conjugate base. So go ahead now and add 15 mils of that, please. A little bit lower, please, Chow. There we go, thank you. Okay, it looks pretty good. So she's going to pour that into the other beaker. Alright, so now we've got our buffer components. Now she's going to make the buffer by pouring one into the other, is that correct?
Yeah.
Okay, let's go ahead and do that. Right, we're going to measure the pH before we put the 30 mils of water in. Turning it on. There we go. Now this one, she's going to just pull that off, that's okay. And she's going to measure the pH. So once that stabilizes, they'll get a pH measurement. And generally, wait about a minute. And if it's still going up after a minute, just take whatever value happens to be on there at the time. That should usually be plenty of time for it to stabilize. Alright, that looks pretty stable. So now what Chow's going to do, she's going to rinse it off. Rinse off the probe with DI water. And she'll put the probe back in its house just by slipping it back on. There we go. And she'll let it sit. Right, now you're going to add 30 mils of DI water, and we're going to take the pH again. Is that correct?
Yeah.
Okay. Now we're not expecting a huge change in the pH here when we add the water, because all the water is going to do is dilute the entire solution. So go ahead and put that in. And it says here to mix it around a bit. We have a stirring rod handy in order to do that. And if you get a paper towel, please, we'll use that to wipe off the stirring rod. Place to put the stirring rod. Just go ahead and put the stirring rod over there. Okay, cool. Now she's going to measure the pH of the solution again after adding 30 mils of DI water. As I said, we're not expecting a huge change here. So let it sit for about a minute, and we'll see what kind of pH reading we get from that. Alright, so Chow's going to take the probe out of here, and she's going to wash it off and put it back in its house. She's just rinsing it off there with some DI water and sticking it back in its house. There we go. Good job. Now what she's going to do, we've got that solution there. It's a solution of acetic acid and the sodium acetate with 30 mils of water. She's going to pour half of it into that second beaker. Just sort of split it between the two equal amounts. There we go. That's good. Alright, thank you. Now what we're going to do is add some 5 drops of sodium hydroxide. Okay, 5 drops of sodium hydroxide, please. Add it to the first one. Okay, let's get a stirring rod and stir that around, please. Okay, now take it out. Now Chow's going to measure the pH of this one we just added the sodium hydroxide to. I'm expecting a small jump in pH. That's good. Let's go ahead and stick it in. I'm expecting a small jump in pH upwards relative to what we started with. So you took the pH of the solution before you added the sodium hydroxide, and now what you're doing is taking the pH after adding 5 drops of sodium hydroxide. That looks like it's stabilized. So leave it in there, please, Chow, and go ahead and add 5 drops of HCl, there we go, to the other one. Okay, good. Let's stir that around the stirring rod, please. She's rinsing off the stirring rod. That's very good technique. Alright, just giving it a bit of a stir. Alright. Now in between, she's going to take the probe out, rinse it off with water, DI water, and then stick it in the other solution. Very nice. Okay, let's go ahead and stick it in the other solution and take the pH. I expect for this one, we'll go down a little bit based on what we had originally started with. So now Chow is going to clean off the probe with DI water and put it back in its house. So now what Chow's going to do is she's going to make up an uneven buffer solution. So 2 mils of the acetic acid she's going to put into a graduated cylinder. I recommend a 10 mil graduated cylinder for this part. So she's going to add 2 mils into that, making sure that the bottom of the meniscus is on the 2. Okay, that's good. Let's pour that into the beaker, please. To the other graduated cylinder, she's going to add sodium acetate, 20 mils. So we've got 2 mils of the acid, now 20 mils of the conjugate base is being added. Okay, that's great. Now go ahead and add them together. Just give it a little bit of a stir with the stirring rod, please. Okay, cool. Alright, let's put the probe in and measure the pH of this uneven buffer solution. So we'll wait for a minute and we will get an idea of the pH here and wait for it to stabilize. Looks like it's already stabilized, so we'll go ahead and mark that down. Now what I'd like you to do is rinse off the pH meter, put it back in its house. And we're going to add, is it 3 mils? Yes, 3 mils of sodium hydroxide, please. So use the 10 mil graduated cylinder. She's rinsing it out with a little bit of water. It's good, good technique. And now she's going to add in 3 mils of sodium hydroxide. And again, she's going to make sure that the bottom of the meniscus is on the 3. Now what we're going to see happen here is this is an uneven buffer mixture. So what's going to happen is the addition of this much sodium hydroxide is going to cause the buffer to overrun. So I'm expecting a fairly large increase, in this case, of pH based on what we saw previously when we were adding a small amount to an even buffer solution. So the sodium hydroxide is going to eat up most of the acid that's in there, and we're going to end up getting a large jump in pH. So well, let's see if that happens. So go ahead and add that in and give it a little bit of a stir around with the stirring rod, please, Chow. Then of course what she's going to do is take the pH of that solution. So we'll take a look at that, and you probably can't see the pH from here, but it's going to be a pretty big jump when we do this. So we'll wait for it to stabilize a little bit. Pretty stable, so we'll go ahead and take that result. Alright, Chow, I'd like you to take the pH meter out and clean it off and put it back in its house, please. Put that beaker off to the side, please, one we just worked with. And now we're going to work with the next one, and we're going to do exactly the same thing as we did previously. We're going to add 0.1 molar acetic acid, just cleaning out the graduated cylinder first. So 2 mils of acetic acid. Then she'll add 20 mils of the sodium acetate to that. And this time though, we will add 3 mils of HCl, and we'll see what the pH change is going to be. Notice that we're making up a new buffered solution here. Alright, very nice. Now she's going to stir it up a bit, that's okay. Now she can add the 3 mils of HCl. No, we don't need to take the pH. We've already taken the pH of that solution once. We don't need to do that again. Now she's adding the 3 mils of HCl, cleaning out the graduated cylinder first, and again ensuring that the meniscus is on the line of 3. Go ahead and add that into the solution and give it a little bit of a stir, please, Chow. Alright, and she's going to take the pH of that solution. So what we're expecting here is a somewhat smaller drop in pH as we take the solution that has a fair amount of conjugate base in it, and we're adding not very much strong acid to it. So some of that will be eaten up, but we're not going to see a huge drop in pH. Now what we're going to do is we're going to have 2 25 ml samples of just regular garden variety water. So Chow, please go ahead and fill up that 50 ml graduated cylinder. You're just going to fill it pretty much close to the top graduation. We're not too concerned about the exact volumes here. Alright, that's good. Alright, pour a little bit out, so we've got 50. There we go. Now she's going to pour about 25 into the first one and about 25 into the second one. Doesn't have to be exact, but anywhere in that ballpark is good. Now what she's going to do is she's going to take the pH of regular water. So we're going to get a value from that after about a minute. That looks like it's stabilized. That's good. So go ahead and rinse it off with DI water, because we like to do that. And we'll put it back in its house. Right, to the first one, you're going to add 5 drops of NaOH. Now this one is not a buffered solution, so I'm expecting a pretty big jump in pH when we add the probe to it. So go ahead and just give it a bit of a stir too, please. Okay. Okay, so we'll get the pH. While that's stabilizing, she's going to add 5 drops of HCl to the other beaker. Yeah, it does look like there's a pretty big jump in pH here. Alright, that looks like it's stabilized, so we'll go ahead and clean that off and stick it into the other beaker. Now for the other one, since again it's not buffered and we're adding HCl, we're expecting a pretty big drop in pH relative to where we started. Did you give that a bit of a stir too, please? So let's stir that up a bit. There we go. That's much better. Alright. Yes, and we're observing a pretty big drop in pH here. Yeah, don't forget to stir it when you do it. And that looks like it's stabilized as well. Alright, it's good. This is part D of the pH and buffers lab. So what we've got here, out the front, we've got an unknown. It's got a certain pKa associated with it. We know that pKa because it's written on the bottle. And next to that, I've got a graduated cylinder with 20.0 mils of that acid inside it. Additionally, we have a burette here, and in this burette we've got 0.1 molar sodium hydroxide, and it's up around the 0.00 mark. Now what Samuel's going to do is he's going to pour in the acid. Hang on, I'm going to zoom in here a little bit. There we go. He's going to pour the acid in to this beaker. And that's good. Now what he's going to do is, oops, no, you need to take the probe out of his house there, Samuel.
Oh, I'm sorry.
So you'll do that by just taking it straight off. You can just,
This whole thing.
you don't have to unscrew it. There you go. That's good. All right. So put that in there. Alright, that's good. So the probe's in there now. The pH meter is on and it's reading a certain value, but we're not going to say what that value is right now. Suffice it to say that we're going to be adding sodium hydroxide and using the stirring rod to stir the solution, and occasionally checking the pH until it gets to the target pH that your instructor has given you. So you've got the pKa, you've got the target pH. You should have already calculated the amount of sodium hydroxide you think you should need, and we're going to verify that that is the exact amount that, or close to the amount that you'll need, by actually doing the titration and getting to that target pH on the pH meter. Alright Samuel, so go ahead and start adding the sodium hydroxide. So add it at first in say 5 ml, or at least a couple of mil increments. Stop there for a second. Yeah, so just add 5 mils. Give it a bit of a stir around. Now if necessary, hold up the pH meter a little bit. There we go, and then stir with the other hand. There we go, it's better. That's probably good technique. Now some people like to use the pH meter to stir with. I'm not a real fan of that. It's a probe, it's not a stirring rod. It's good. Alright, take a look at you should always be monitoring the pH meter as well to make sure you haven't overshot the target. And it haven't yet, right?
No.
Okay. So what we're expecting obviously is if we're adding sodium hydroxide, we're expecting this pH to go up. So add a little bit more to stop there. Monitor the pH, make sure you haven't overshot it yet. Right, you're still a fair way away?
Yes, I am.
Okay, good. Now I think from this point he might want to slow it down a bit. So he's just going to do a slow drip, 1 drop at a time, Samuel. There we go, that's good. And now he's going to stir it and continue to look at the pH meter, see what's happening to it. Does it seem to be a fair way away?
Yes.
Okay, in that case, then go ahead and add another full milliliter. Give it a stir. How are we looking now? Still a fair way away? Alright, add another 4 milliliter. Okay. Yeah, go ahead and add another milliliter, Samuel. Looks like we're getting close to our target. So what do you reckon? Are we about 0.1 away now?
Yes.
Okay, so let's go ahead and just add it drop-wise, 1 drop at a time. Okay, now stir and monitor the pH meter at the same time.
Alright, we're there.
Are there? Okay, stop it. And there we go. So what's going to happen then is that Samuel's going to read off the burette how much sodium hydroxide has been added, and then that's hopefully comparable to the value that we just calculated earlier for the amount of sodium hydroxide that needed to be added in order to get to our target pH.